Hi, George Diamond here. Now today we're going to take a look at two velocity acceleration problems involving motion along a line. This is our second video. In video number one, we looked at a position and a velocity graph. So we looked at two graphs and looked at some questions involving the graphs. We reviewed velocity acceleration as it relates to the derivative. And we looked at the generic formula for displacement of a free-falling object. Now today we're going to take a look at two problems and involving velocity acceleration and several components to each problem. But let's start off with our first question here. This is example number one. It says, if the position in feet of a particle P moving horizontally along the x-axis is given by the equation S of t equals t cubed minus 10t squared plus 25t, where t is greater than or equal to 0 seconds. So the position is in feet, time is in seconds in this problem. Right. Now, couple parts to this problem. Here's the first part. Okay, part A. All right, first, let's see if we can evaluate the position at 1, the position at 4, and the position at 5, and interpret the results. What does that mean? Well, let's take a look at the position of the particle at 1. So once again, keep in mind the particle is moving horizontally along the x-axis. So to evaluate the position at 1, we're going to take S of 1 would be substituting 1 in for t. It would be 1 cubed minus 10 times 1 squared plus 25 times 1. And once again, I apologize for my poor penmanship, but hopefully you can interpret my results here. Okay, evaluating this, we get 16. Okay, let's evaluate the position at 4 and 5. So the position at 4, okay, now I've already evaluated this as 4, and then the position at 5, so basically you're substituting into your position function. Now the position at 5 is at 0. So you can see after 1 second, the particle is at 16. After 4 seconds, the particle is at 4, and after 5 seconds, the particle is at 5. Now, what do these mean? Now, first of all, at 1 second, so let's say after 1 second, OMD, so after 1 second, okay, P, our particle, has moved. So it has moved 16 feet to the right of the origin. So move 16 feet, okay, to the right, okay, of the origin, of its starting point. Now after 4 seconds, after 4 seconds, the particle is 4 feet from the origin. So it's 4 feet from the origin. And last, after 5 seconds. So after 5 seconds, the particle is back where it started from. So it's back at the origin. So it's back where it started from. So at 5 seconds, its position is at 0. That means it's 0 from where it started, so it's basically back where it started from. After 4 seconds, the position is at 4. Now keep in mind, the particle may have changed directions in that time, all right? And obviously it has. So after 1 second, the particle's at 16. After 4 seconds, it's at 4, so you can pretty much conclude that it's changed directions there somehow. And after 5 seconds, the particle is back where it started from. So this is what we can interpret from our results. Okay, let's take a look at the second part of the problem. This is part B. All right, now at what time or times is the particle not moving, and why? So when is it not moving? Now the particle is stopped. So the particle is stopped when the velocity is equal to 0. So the velocity is equal to 0. So we've got our position equation here, t cubed minus 10t squared plus 25t. Let's find the velocity equation. Now the velocity, remember, is the first derivative, so getting our velocity equation, okay, v sub t will be equal to, taking the derivative of t cubed would be 3t squared, okay, minus the derivative of 10t squared would be 20t. The derivative of 25t would be 25, so plus 25. So this is our velocity equation. Now let's set the velocity equal to 0. That gives us 3t squared minus 20t plus 25 is equal to 0. Now we just solve this for t. Now there's no common factors, so this is a trinomial. Let's see if this one can be factored, can be solved by factoring it. Now 3t squared will factor as 3t and t. 25 will factor, let's let that factor as 5 and 5. Now the signs are both going to be a minus and minus. So we got 3t minus 5 is equal to 0. T minus 5 is equal to 0. And that means t will have to be equal to 5 over 3, and t is equal to 5 seconds. So we can conclude now, right? So this is where the velocity is equal to 0. Okay, that means that the particle p is stopped. So the particle is stopped at 1 2/3 seconds and 5 seconds. And so we got to justify this, right? So and why, all right? So and why? Because, okay, we can conclude that probably because the particle, so the particle is changing directions. So the particle is changing directions. Now, that's probably the case. Now the particle may have stopped. It's possible for the particle to stop and not change directions, but because that's probably if you had to give a reason why it stopped, that would probably be the best reason. So it's probably changing direction along the x-axis. But keep in mind, the particle can stop and then not change directions though. But that's probably a conclusion we could come to. Okay, from part B. Let's take a look at part C. Now part C. All right, and once again, we're using our same position equation here, same position function. Now for part C, it says, on what interval of time is the particle moving to the left? So what interval of time is the particle moving to the left? All right, now we'll see, we've already got our critical numbers. So we've got our critical numbers was what, 5/3 and 5. So let's do a little, so it's moving to the left. Let's do a little number line graph, if you will. All right, so a little number line graph. This will be at 0. Actually, it'll be at 0 here. Okay, let's put the 1 2/3 here. Let's put 5 on our number line here. All right. Okay, so let's see now. The particle is going to be moving to the left when the velocity is negative. It'll be moving to the right when the velocity is positive. So let's pick us out a test value of each interval here. Okay, this will describe the velocity. This will describe the motion of the particle. So above the number line, I'll describe the velocity, and below the number line, we'll describe the motion of the particle. So we'll pick us out a couple of test values. Let's try, we'll try 1. Let's say, we'll try 2, and let's try 6. So we'll try these 3 test values between our 2 critical numbers, all right? And let's see what's happening now. Let's try, so once again, take your each test value, let's substitute it into our velocity function. Right, so the velocity at 1 second would be, and once again, keep in mind, the actual number doesn't matter. What matters is whether the number is positive or negative. If the number is negative, it indicates the particle is moving to the left. If the number is positive, then the particle is moving to the right. So let's take the 1 and substitute into our velocity function now, which was 3t squared, so it'll be 3 times 1 squared minus 20 times 1 plus 25. Right, now evaluating this, we get, 3 would be 8. Right, now that's a positive 8, so this is positive. So like I said, the 8 itself, it doesn't matter, it's just positive. Right, so that means that the particle itself would be moving to the right. Right, from 0 to 1 2/3. Let's try the other test value here. So substitute 2 in. Okay, this would be 3 times 2 squared minus 20 times 2 plus 25. And this will be equal to negative 3. Okay, now we can conclude since it's negative, the particle is moving to the left. And let's try the velocity at 6. So it'll be 3 times 6 squared minus 20 times 6 plus 25. This time at 6 the velocity would be 13. So once again this is positive. So that we can conclude the particle is moving to the right. So from 5 on the particle is moving to the right. Now the question asks, when on the interval is the particle moving to the left? So let's make sure we actually answer the question. So it's going to be moving to the left on the interval from 1 2/3 to 5. So the particle is moving to the left on the interval from 1 2/3 to the 5. And once again, just do a little number line graph. Pick out a test value off each interval there, substitute in your velocity. If the velocity is negative, it's moving to the left. If it's positive, it's moving to the right. And that'll answer part C of our question. Now we got one more part on this problem. Okay, let's try part D. So let's try part D. It says, how far does the particle travel in its first 4 seconds of motion? So the first 4 seconds of motion. Now, an obvious incorrect answer would be 4. Because if you remember in part A, we said the position at 4 was 4. So after 4 seconds, the particle is 4 feet from where it started from. So that would be an obvious incorrect answer. So that is wrong. So after 4 seconds, keep in mind the particle actually changed directions in there somewhere. Now we had, so let's see, so let's say this is, we're looking for the net change this time. So to start off, now it said we had 2 critical numbers. We had the 1 2/3 and 5. So let's see, so somewhere in there the particle changed direction at 1 2/3, right, or 5/3. So let's start off. Let's see how far the particle traveled in the first 1 2/3, all right? And then it must have changed direction there. So let's find the position at the first critical number here. So the position at 5/3 would be, now the position function would be 5/3 cubed, okay, minus 10 times 5/3 squared, plus 25 times 5/3. And let's see how far the particle has traveled before it changed direction. Now if you evaluate this, you get about 18.158519. Now, students that are taking AP Calculus, now this number you don't want to round off too soon. If you remember on the AP Calculus exam, your final answer has to be rounded off to 3 decimal places. So this number you don't want to round off to 3 decimal places. If you do, it'll give you a rounding error, could possibly give you a rounding error in your final answer. So I'm going to take this out past 3 decimal places, well past. So at the first critical number, right, where the particle apparently changed direction, it's already traveled 18.18519 feet. Okay, now where's the particle now after 4 feet? So we said the position of the particle after 4 feet was 4. So what's happened is this. So if you can imagine this now, the particle at 0 has traveled to the right 18.158519 feet. Okay? All right. Now that, and then after 4 seconds, the particle now is 4 feet from where it started. So it's also, it's gone to the right 18.1 feet, and then it's come back to the left. 18 minus 4 would be 14.158519. So it's gone back to the left 14.1 feet. So to get the total distance traveled, we're going to have to add the distance the particle traveled to the right plus the distance the particle traveled to the left. So remember, it's 4 feet from where it started from, and it went over 18 feet. Now it's gone back 14.1 feet. So let's add the 18.158519 plus 14.15819. Adding the two together and rounding off gives us about 33.037 feet. So this particle has traveled 33.037 feet. Now, students that are taking AP Calculus, you want to round your final answer off to 3 decimal places, all right? If you round off too soon, it could give you a rounding error, and we don't want that. Okay, so this is a nice little problem to start with. So this is our first example. Okay, let's try problem number 2. So let's bring in problem number 2. All right, now here's our second example. Our second example says an object moves along the x-axis with displacement from the y-axis given by x of t equals 3t cubed minus 30t squared plus 64t plus 57, where x is greater than 0. X is in miles and t is in hours. All right, so we're talking about miles and hours. All right. Now, our first question, that's part A. Okay, let's see if we can find equations for the velocity and acceleration. So let's see if we can get equations for the velocity and the acceleration. Well, the velocity is the first derivative. Acceleration is the second derivative. This will be pretty easy here. So our velocity, so v sub t, our velocity equation should be 3 times 3 is 9. So it'll be 9t squared minus 60t plus 64. So this will be our velocity equation. Okay, let's get the acceleration equation. Now the acceleration equation is 18t minus 60. All right, so once again, we got our velocity and our acceleration equation. So part A was actually pretty simple. You know, students that take the AP Calculus exam, you know, you can see these types of problems all the time where you're going to have to maybe just come up with the, so one part of the problem may ask you to come up with the velocity and the acceleration equations. So this will answer part A. Now let's take a look at part B. Now once again, you need to remember this answer here, right? Because we're going to be using this later on in some of our other problems. Take a look at problem B now. Now part B says we're going to find the velocity and acceleration at 2 hours, 4 hours, and 6 hours. Now at each time we're going to state whether x is increasing or decreasing, and at what rate, and we're going to tell whether the particle is speeding up or slowing down. So we're going to give us some information here now, and we're going to have to use our velocity and our acceleration functions that we just wrote in part A to answer this question. Now to do this, I'm going to fix up a little chart. Right, so this will kind of summarize the information quite nicely, hopefully. So I'm going to fix up a little chart. Let's put the time here, so a column for the time. Let's do a column for the velocity and a column for the acceleration. Okay, let's do a column to tell whether the function is increased, whether the particle is increasing or decreasing. So increasing or decreasing. And let's see, one more column here. We got to tell whether it's speeding up or slowing down. So speeding up or slowing down. Now, if you remember in my first video, we said the particle is going to be speeding up if the velocity and acceleration have the same signs. It's going to be slowing down if the velocity and acceleration have opposite signs. So, okay, let's take a look at our first time. It said at 2 hours. So we're going to put 2 here for the time. And so let's see, v sub 2. So let's see, let's take 2, substitute into our velocity function that we just wrote. So v sub 2, okay, would be 9 times 2 squared minus 60 times 2 plus 64. Now, evaluating this, we get the velocity is negative 20. All right, so I'm going to put that right here, so negative 20. Let's get the acceleration also. Now, we're going to use the acceleration function this time. So the acceleration after 2 hours was 18 times 2 minus 60, minus 18 times 2 minus 60. So hopefully you can still see this okay. And which is negative 24. So let's put that right here. So negative 24 under the acceleration column. Now you can see now the velocity is negative, so the particle is decreasing. All right, so it's going to be decreasing at 20 miles per hour. So the particle is decreasing at 20 miles per hour. Okay, also you'll notice that the velocity and the acceleration are both negative. So the particle is going to be speeding up. Okay, they got the same signs. So we have to tell how we decided, right? So it's going to have the same signs. Okay, let's do the same thing with 4 hours. So let's take the 4, plug it into our velocity. Now for to speed this along a little bit, I'm going to go ahead and write these values in. But once again, you're going to substitute 4 into your velocity function. Okay, that'll give us negative 32. Substituting 4 into the acceleration function gives us 12. Now, to decide whether the particle is increasing or decreasing, right? Now the velocity is negative, so once again, it's decreasing at 32 miles per hour. So the particle is going to be decreasing at 32 miles per hour. Okay, once again, you'll notice that the velocity and acceleration have opposite signs this time. So the particle is going to be slowing down. So the particle is slowing down. Now to give a reason, they've got opposite signs. All right, so they're going to have opposite signs. Now let's take the last time, let's take the 6. Let's try the same thing with 6 after 6 hours. Now, substituting 6 into our velocity, we end up with 28. All right, and the acceleration at 6 would be 48. Okay. Now this time the velocity is positive 28, so the particle is going to be increasing, okay, at 28 miles per hour. All right, so it's increasing. Now to determine whether it's speeding up or slowing down, you notice that the velocity and acceleration are both positive, right? So this time it's going to be speeding up. So that once again the particle is speeding up, and they've got the same signs. Okay. And once again, now you got to remember now to determine whether a particle is speeding up or slowing down, you have to compare the velocity and the acceleration at that particular time. If they got the same signs, the particle is speeding up. They got opposite signs, it's going to be slowing down. Okay, this is part B of our question. Now, once again, we're going to use the same position of function again. And we got one more part here to do. Okay, let's take a look at part C. Now, once again, using our position function, said at what time or times in the interval from 0 to 8 is x a maximum? Is x ever negative in this interval? Now you notice right away that this is a closed interval, all right? So this is closed. That means that the endpoints can be maximum minimum values. All right, so with this last part, we want to start off by finding our endpoints. So I'll go ahead and do that first. I mean, we're going to have to do it eventually, so let's go ahead and get our endpoints. Now to get the endpoints, let's take the 0, substitute it into our position function, and let's see what we get here. All right, so let's get that'll be x of 0. Now we're going to substitute 0 into our position, and let's see what we get. This will be 3 times 0 cubed minus 30 times 0 squared plus 64 times 0 plus 57. Now, evaluating this, we get 57. Okay, now that'll be the point 0, 57. Now, let's try the other endpoint. Now, once again, we're going to be comparing our y values. We're going to get our critical numbers here in a minute also. And let's see, next let's try the position at 8. So x of 8. Now substituting 8 in for x in our position function, again this will be 3 times 8 cubed minus 30 times 8 squared plus 64 times 8 plus 57. Now evaluating this, we get 185. So this would be 8 and 185. just looking at the endpoints right now, the 185 would be the maximum. All right, so we're looking for, says that what time on the interval from 0 to 8 is x a maximum. So right now the maximum would be after 8 hours. So the maximum would be 108 feet, 108 miles, I'm sorry, it's 108 miles. Okay, next we're going to have to get our critical numbers. Now to get our critical numbers, or let's see, in this case, so we got our endpoint. So to get our critical numbers, that would be using our velocity. So let's see where the particle is changing directions at. It's going to change direction when the velocity is equal to 0. So to get our velocity, now the velocity, finding the derivative here. Now we got our velocity function earlier. Now the velocity would be, let's see, remember the velocity, said the velocity equal to 0. We did that in part A, would be 0 equals 9t squared minus 60t plus 64. Now we'll get to solve our velocity, our equation here for t to get our time values, right, when our velocity is equal to 0. Now solving this for t, I believe this one we can just solve by factoring it. So start our factorization here. I think 9t squared will factor is 3t and 3t. Now 64, let's try 16 and 4. And the signs will both be negative. All right, now let's see. Let's take the 3t equals 0, equal 4. Solving for t, t equals 4/3. So our first critical value will be 4/3. And let's take 3t equals 16. T equals 16 over 3. All right, so we know when the particle is changing direction, or it's stopped at each of these at 4/3 and at 16/3. Now, let's try each of these critical numbers now in our position function. Let's see what's happening now. So let's take each of these, substitute into our position function. Let's see if we get a value greater than 185. So let's try the 4/3 first. So the position at 4/3. All right, now once again, this is 3 times 4/3 cubed minus 30 times 4/3 squared. Okay, plus 64 times 4/3 plus 57. Now this time we end up with a 96.1. Now that'll be 4/3. Now I'll just give us the decimal here, so 96.1. And still 185 is our biggest value still, all right? So let's try our other critical number this time. So let's try x of 16/3. So once again, substituting 16/3 in for into our position for t, and this will give us 3 times 16/3 cubed minus 30 times 16/3 squared plus 64 times 16/3 plus 57. Now evaluating this time we get 0.111, right? So that'll be 16/3 and 0.111. Now 0.11, this would be a minimum value, so that'll be a minimum. Now one of the questions that was asked in the problem up here says, is x ever negative in this interval? So the answer is x is never negative, all right? So negative. So you can see the minimum is at 0.11 and x is still positive. Now looking for the maximum. So the maximum value is still 185. So this is going to be the max. And so we have an absolute maximum at, let's see, what we asked for, so at what time? So at t equals 8, that's the absolute maximum. So we're asked for the time value, so at x equals 8 hours. So let me get that in there too. So 8 hours, we have an absolute maximum value. Okay, now what you saw here was just 2 problems, right? So several different parts to each one. These are the top questions if you're taking the AP Calculus exam at the end of your year. If you're taking AP Calculus, you see these velocity acceleration questions all the time. So hopefully maybe this will kind of help as far as your understanding of velocity acceleration as it relates to the derivative. Now my students, we've not looked at integration yet, so that we'll do another video later where we get into integration and using velocity acceleration there. But for right now, this is just using derivatives and how we use velocity acceleration to describe a particle motion along a line. So hopefully you found this video helpful. If you haven't seen video number 1, you can take a look at video number 1. It describes some more information. But hopefully you found these two videos or this video helpful.